Hi everyone, welcome to this demonstration of my Langston and parallel simulation projects. So I make this project for my parallel and distributed system. So in this video I'll explain the purpose of each class, how the codes works and how everything connects together. So let's start with a quick recap. Langston Ant is a two-dimensional Turing machine with a very simple set of rules, but it produces complex behavior. So I create five classes like ant.java, grid.java, Langston and visualizer.java, main.java, and performance tester.java. So now let's see ant.java. This class represents an individual ant in the simulations. So the ant class implement runnable, so each ant can run in its own thread. So it has properties for the positions like x and y. These are the positions x and y. So direction, grid, color, running, pose, speed. So the constructor initializes these values as in the random color and sets initial speed. So now you can see, yeah, in here, if one color black cells, if the cell is black, it's turned left. If it's white, it's turned right. So the flip color of the cell make this. So you can see here. Then I made the run function. Before that, I made the move functions. Yeah, I forgot this. So the move functions methods, this method moves the ant one step in its current direction. I mean the north or east, south or west. So it can tell the movements of the ants. And now I'm come to the run method. So this method continuously run steps in a loop, pausing and adjusting speed as need. Now going to see about the grid class. So this class represents the grid where the ants move. So I use the concurrent have map. So this stores cells where each cell in is a point object and it's in a boolean indicating whether it's black or white. So I go about, yeah, flip cell method. I include the x and y. So this synchronize, I mean I'm public synchronize void flip cell, input x and y. So if the cell is black, I mean I put the function for the black, the x and input x and y. So boolean is black, x comma y. So then its get returns to the entire grid map. So get self this returns to the entire grid map. Then the clear method is to reset the grid. So these are the function. It's working like this. Now this is the main class, the Langston and visualizer. So this is the graphical user interface class for the simulation. I create like this for the user interface, for my user interface. So in here, extend JFrame and creates a swing window. So I use the JFrame and the swing to create this graphical user interface for this Langston and visualization, because how it's the ants are running and make the highways. That's our output. So we're going to see that. So before we go to see, so let's explain this code. So public class, I create a Langston and visualize a class extend JFrame. So it contains a grid panel for drawings the ants and cell, and I put the paint component method handle drawing bag cells and ants. So here here you can see the component paint component method. So I use this for the handle drawing back cells and ants. So it's the movements. It's like it shows the drawing of where the ants moving. So we can see the ants movement. For this, it's make the color, choose the color and handle the ants movements. Then I add the function the buttons. So I add J buttons. So you can see the add and pause, resume and resume and the clear view. And you can see the speed, adjust the speed as well. So I put the button for adjust speed. So you can see we can when I run, so we can see this. So then I put another method private void add and so this method creates a new and instant add it to list and start it in a new thread using execute service. So I use this for the and add into the list and start it in a new thread using execute service like that. So and use here you can see the post and another one is resume and so these two methods control the simulation state. So these two I mean the post and func method and the resume and method control the simulations and the time triggers period represent the grid panel. Yeah, and this is the main class. I create this for simply launch the Langstroth and visualizer by calling main method. So this create for the main method. So now I'm going to so this the performance tester Java file. So this class I create this for because the testing the simulation performance in both sequential and parallel method. So I use this tester, I mean the performance tester for run the code within the parallel and sequence so sequential time. So we can see we can compare in sequential time so how long it take to finish the ants I mean the highway map road map and in the parallel how the ant how long it take to finish. So you can see run sequential test method. So this run sequential test um, runs a single ant for 100,000 steps and measure execution time. So this for the sequential time I create this and you can see the sequential test. So private static long and run sequential test method. I use this and create new grid. So and I put the name as and the new and x and y and the green. So it is for the run sequential and execute the step and sequentially and we can see so how long it take to finish how what's the execution time we can see. Yeah, and this the code for the run parallel test. So they start multiple ants in the separate threads. Yeah, the multiple ants in a separate thread and times how long it take them to complete 100,000 steps each. So I create like you can see number of threads this 10, 20, 30. I took to is 3. I'm going to compare these 10, 20, 30 threads within the sequence and the parallel. These are the threads in the parallel ways. So I'm going to check this. So it's calculate the speed up and efficiency matrices, then print the results. So here you can see I calculate the display speed up and efficiency. So this is the function for the calculate the speed up and this is the function for calculate efficiency for the parallel way. So we can when I run can see so how long it take to finish and in the parallel and the sequence way times. So yeah, let's go to run the code. First I'm going to run the main class, main.java. So going to run. So this function is working. So this is the user interface for Langston and simulations. So now I'm going to add one and in a sequence method. So I add one and so it's moving. So I can adjust the speed. So you can see now it's slow, so a little bit fast, so fast. So I can feed. So this the higher speed for this and so it's for going very fast. Then I'm waiting for the result. It's making the highway. Yeah, this done. And I clear this view. Now I'm going to add two ants. You can see two ants. And I can pause this. I pause this. So it's stopped. Now I resume this. So it's working. So I'm waiting for the result from the highway. These two ants are making. And I also reduce the speed and increase the speed like this. So I increase the speed in the highest speed level. Now let's wait for the results. You can see the results. Now I clear this view, add two more ants, three ants, four ants. Yeah. The first thread creates the skyway and the second one creates its skyway. So we can see the time it's take to create to for the finish its highway. So this one execute first and this one secondly executed and this one executed in the third and this execute the lastly. So you can see in this diagram, so sorry, in this simulation, so how long it's take to run this. Now I close this window and I'm going to test in a parallel and the sequential method. So I run this code and we can see how long it's take to finish the threads. You can see the performance test Langstones and so sequential execution time for the sequential execution time is 45 milliseconds. In the parallel, I first 10 threads, it takes 306 milliseconds, and the 20 threads, 616 milliseconds, 30 threads, it's 871 milliseconds. So, and you can see, I showed you the methods for the speed up and efficiency. You can see the speed. So, I put the speed up and the efficiency for the 10 threads and this 0.14 and the 20 thread 0.07. You can see the speed, and in 30 threads it's 0.05 and the efficiency as well. So you see, yeah, and that's the overall structure for my Langston and visual simulation. So this simulation lets you visualize Langston and behavior, control the simulation in a real time, and test how well it's performed with parallel execution. You see before here. So this the behavior of ants behavior and the control simulation real time and the test how well it's performed. So we see this. So uh, that's all. So and I need to tell I learned a lots of things in this parallel and distributed system. My lecturer taught me a lots of uh, things. I learned a lot and I learned the parallel and the sequential method. So I learned a lot. So in this chapter, give me a lots of knowledge, and I use this knowledge in my future work. So this time I'm going to finish this. If there are any questions, you can ask me. So thank you very much. Thank you very much for everything.